Welcome to EduPorm EdTech. You're watching expert chemistry lectures with Abhinav Gaur. Today we will discuss the solubility of solids in liquids. We will assume a binary solution in which the solute is in solid state, and the solvent is in liquid state. So the process of addition of solid solute in a liquid solvent at constant temperature and pressure is called as dissolution. Okay, so what is dissolution? It is simply the process of addition of solute in the given solvent. Now, dissolution results in formation of two types of solutions. First, it results in formation of the saturated solutions, and second, it results in the formation of unsaturated solutions. Now, saturated solutions are those in which no more solute, can be added at given temperature and pressure. Whereas unsaturated solutions are those in which more solute can be added at given temperature, pressure and concentration of solvent. Now, what happens after the formation of saturated solution? So, for example, this is NaCl in the solid state, and this is our solute, and this is water in the liquid state, and it is our solvent. So, I am adding NaCl in water. NaCl is getting dissolved. Then there will come a stage where no more NaCl will get dissolved unless I increase the temperature. So at that stage, saturated solution will be formed where no more NaCl can be dissolved at given temperature, pressure and at given concentration of solvent. So if I keep on adding my solid solute in the saturated solution, then the addition of solid solute in the saturated solution will result in collision between the solid solute particles and the aqueous solute particles. That means the aqueous Na positive ion and the aqueous Cl negative ion, which are present in the brine solution, or we can say saturated solution formed by dissolution. Okay, so when I am adding NaCl in water, what is happening? Dissolution is happening, and in case of dissolution, NaCl is getting converted into Na positive and Cl negative, and these ions are dissolved in the H2O. That means dissolved in water to form solution called as brine solution. So when we are taking the case of saturated solution, the saturated solution will have Na positive ions and Cl negative ions present in it. And when I will add more of solid solute, this is our solid solute. So when I will add more of solid solute in the saturated solution without changing temperature, pressure and concentration of solvent, then the solid solute particle will collide with these aqueous solute particles present in the solution, and as a result the solid solute particle will get separated out. They will deposit at the bottom of flask and they will form crystals, and the process is called as crystallization. So what is crystallization? When solid solute particles are added to a solvent, the process is called as dissolution. Dissolution results in formation of saturated solutions. Saturated solutions are those in which no more solute can be added at given temperature, pressure and concentration of solvent. And if we add more of solid solute in a saturated solution, then solid solute particle collide with aqueous solute particle present in the saturated solution, and the solid solute particle gets separated out. They deposit at the bottom of flask forming crystal. and the process is called as crystallization. Now, this is the case where solute is getting dissolved in the solvent. And what if the solute is not getting dissolved in the solvent? So, let's study the principle of like dissolve like. For example, if I am taking sugar and I am taking salt, we know that sugar and salt, both of them get completely dissolved in water. But if I have naphthalene, if I have naphthalene or if I have anthracene, both naphthalene as well as anthracene are insoluble in water. Both of them are insoluble in water. That means they will not dissolve in water. Next, we know that naphthalene and anthracene are soluble in benzene. They are soluble in benzene solvent. Whereas if I talk about sugar and salt, they are not soluble in benzene. Okay, they are insoluble in benzene. So why the sugar and salt were soluble in H2, and why sugar and salt are insoluble in benzene, while why naphthalene and anthracene were insoluble in water while they are soluble in benzene? This is because like only dissolves like. And what does it means? It simply means that polar get dissolved in polar and non-polar get dissolved in non-polar. Okay, so sugar and salt, they are polar, so they are getting dissolved in polar solvent, that is H2O. Naphthalene and anthracene, they are non-polar, so they are getting dissolved in the non-polar solvent, that means benzene. And what is this polarity? Let me explain by means of two examples. For example, if I am taking H2O, so this is the structure of H2O. In this structure, oxygen is more electronegative than hydrogen. So the polarity will be towards oxygen, and the overall polarity will be towards this side. So in this case, there is a direction of overall polarity, and overall polarity exists because there is difference in electronegativity of the two atoms present in a bond. Similarly, in case of NH3, this is the structure of NH3. NH3 has T-shaped structure, but because of the presence of lone pair and VACPR, the structure become bent. So we have hydrogen, we have hydrogen, we have hydrogen. We know that nitrogen is more electronegative than hydrogen. So this is the direction of polarity. This is the direction of polarity, and again this is the direction of polarity, and this is the overall direction of polarity. So both H2O as well as NH3 are polar in nature. They are both polar. But if I take the case of, let's say, CCl4, so in case of CCl4, we know that chlorine is more electronegative than carbon. So this is the direction of polarity, this is the direction of polarity, this is the direction, and this is the direction. Now in case of CCl4, the overall dipole is 0. The overall dipole moment is 0. Why? Because this will cancel out this one and this will cancel out this one. So CCl4 is non-polar, and the principle of like dissolve like states that polar dissolve in polar while non-polar dissolve in non-polar. So let's study the effect of change in temperature and effect of change in pressure on the solubility of solids in liquid. We know that the process of addition of solute in a given solvent is called as dissolution. And if the dissolution process is endothermic, that means if heat is getting absorbed during dissolution, then delta H of mixing, yani change in enthalpy of mixing, this will be greater than 0. That means change in enthalpy will be positive and the reaction will be endothermic. Whereas if during the process of dissolution heat is getting released, then change in enthalpy of mixing will be smaller than 0. That means it will be negative and the reaction will be exothermic. So for endothermic reactions, solubility is directly proportional to temperature, whereas for exothermic reaction, solubility is inversely proportional to temperature. So if the result of dissolving solid solute in a solvent, in a liquid solvent, results in absorption of heat, then solubility will increase with increase in temperature. Whereas if the process of addition of solid solute in a liquid solvent will result in release of heat, then the solubility will be inversely proportional to the temperature. Now, what is the effect of pressure on the solubility of solid in liquid? So, as we already know that solids as well as liquids, they both are incompressible. Okay, they both are incompressible. So, because they are incompressible, there will be no effect. There will be no effect of change in pressure on the solubility of solid in liquid. Thank you.